So for ellipses, we had two general forms. So your first form can be with the major axis as the x-axis. So you might have something that looks like this. Okay. Your focal points will be on the major axis, the long axis. So the major axis, that's the long axis. Okay, and the minor axis is the shorter one. So this is the minor axis for this case. Okay, so this is the y-axis, this is the x-axis. Now, we always call this length here actually is A. So this length is A. So when we come to other questions later on, it's actually the length that's A because we're going from 0, 0. So we'll just call that A. So this length is actually A. And this length here is B. That would be B. Actually, A is here. That's the focal point. So let's tidy that up. That's A there. And this is your focal point. Could be somewhere there. We'll call that C. Okay, so that's your first general form. And for example, we should actually write out what that would be. That would be x squared on A squared plus y squared on B squared equals 1. If it's not in this standard form, you need to make it look like that form for many questions. So this is your standard form here. So this is one kind. So note how A and X match together. Okay, A and X and C will carry together. C and A will stay together. So we've got XA and YB here for this case. So as an example, we could have x squared on 16 plus y squared on 4 equals 1. So then we might want to know what A and B is. So it looks like it's in the standard form, but we have 16. We don't have it to power 2. So this would be x squared on 4 squared plus y squared on 2 squared equals 1. Like that. So then we can actually see what the A value is here. A is going to be 4 because the general form here is written there. So you can see that A will be 4. A will be 4, not X. So A will be 4, and here B will be 2. So for this diagram, A will be 4. So this would be 4, and B would be 2. This would be 2. And this would be -2, and this would be -4 when your center is 0, 0. So that's basically what your graph would look like. And I may want to know now what are the focal points? So how do we get the focal points? There is a relationship between the focal point and A and B. So that C squared is A squared minus B squared. So this is one formula you'll need to remember for finding the focal points. So C squared is A squared. So it's basically these two numbers here, 16 minus 4. And B squared is 4. So you'll get 12. C squared is 12. So C will be plus or minus root 12, which is plus or minus 2 root 3. So that would be this value here, C. So this would be 2 root 3, and this would be -2 root 3 on the other side. So that formula is used for getting your focal points. And we may want to know about the sum of focal radii. So the sum of focal radii. That's given by the formula 2a. And I'll show you why it's that formula in a minute. We can quite easily see why it's 2a. So the sum of the focal radii is when we add up the two lines that were formed. So we could have this one here and we can come down to here. So those two dotted lines, when you add those lengths, you'll get 2a. It's equal to 2a. So in this case, a was 4. You see here, a is 4. So 2 4s are 8. And that would be the sum of focal radii for this particular question. So if you wanted to add up this red line, any point on the graph to there, the sum would be 8. So this could be 6 and 2, 3 and 5, for example. Anything that adds up to 8 as an example, but it's a constant number. So that number doesn't change for this whole picture. So wherever you are on the graph, then you still get 8 for the sum of those two radii. So in question 1, we want to find the x and y intercepts of the ellipse and tell on which coordinate axes the foci lie. So the first thing you should really do with these questions is to rewrite it in the standard form. It already is, but I want to make 16 and 25 as powers. So x squared on 16, which is 4 squared, plus y squared on 25, which is 5 squared, equals 1. So we try to get it in this form here. And at this point, I would try to get an idea of what the graph looks like before I try to calculate anything, because my answers will come from the graph anyway. So we've got the x-axis, we've got the y-axis here. And notice now that x matches with 4 and y matches with 5. So what we need to do then for x is just count 4 units to the right. 1, 2, 3, 4 here. And then we count 4 units to the left. -1, -2, -3, -4. Okay, so these are your x-intercepts. So we've got them already, actually. And your y-intercept for 5, we count up the y-axis 5. So 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So we can label them as 5 up here and -5 down here. So in your graph, we could get an idea of the graph. So it's going to look like this. My scale is not quite correct, so you need to be a little bit careful answering the problem. Okay, so it looks something like that. It's almost a circle because these numbers are almost the same. They're quite similar. But my scale is not quite correct. So we need to be careful when we answer part of this question. So when you look at the problem, we can actually see the x-intercept already. So your x-intercept are 4, 0 and -4, 0. And your y-intercept will be go up. Now this would be 0, 5, remember. This is 0, 5. And the other y-intercept is 0, -5. Okay, so we've got this all done. And it says, what axes do the foci lie on? Now, the long axis is this one here. This is the longest axis. This is the major axis because it is 10 units long. This axis, the y-axis, is only 8 units long. So the major axis is the y-axis. So your focal point must be on the y-axis, the long axis. So we could say axis y, or the y-axis is the long axis, is the major axis. So foci, so the foci, I should write, are on the y-axis. So the foci are on the y-axis. I'm not going to calculate them. I just want to know where they are.